doing it. Okay, here we go. I wanted to make a part 2 video to the L'Hopital's lesson as a follow-up because I was watching the original video and I realized that I completely failed to mention why we're doing L'Hopital's. So that might be important information to have. So I just want to go through a couple more examples real quick and talk about just a few more things. First, I would like to find the limit as x approaches 0 of sine x over x. As with all limits, we should start this thing with plan A. If you plug in 0, you get sine of 0 over 0, which is 0 over 0, which is indeterminate. Because this result is indeterminate from plan A, that lets us use L'Hopital's for plan B, which is a good thing because without L'Hopital's there is no plan B here. Plan B is to simplify this thing. The original plan B was to simplify this, see if we could clean it up. In the past that has involved factoring, that has involved rationalizing denominators, that has involved multiplying by conjugates for radicals in various places. Sometimes that involves finding a common denominator and adding pieces of fractions together. Those are all different ways that we simplified it for the original plan B. There is nothing you can do to this. There's no trig identity that will make this simpler. There's no factoring that can be done. It's just sine of x over x. There's nothing you can do to that that'll make it not give you an indeterminate form when you plug in this number. So, it's for problems like this that we have L'Hopital's, and we get to use our alternate plan B. So we're going to L-hop this. L'Hopital says that we get to take the derivative of the top and the bottom separately. That's the other thing I wanted to mention that didn't end up on the other video. This is not a quotient rule situation. You're not taking the derivative of sine x over x. You don't have to use the quotient rule. You're taking the derivative of sine x, and you're putting that on top, and then you're taking the derivative of x, and you're putting that one on the bottom. That's it. No quotient rules involved. So, we L-hop it, we get the cosine of x over 1, and then we plan B L-hop, still don't know what to call this. Plug your number in x equals 0, plug that into the L-hopped version of this limit. You get cosine of 0 over 1, which is 1 over 1, which is 1. The limit of sine x over x, as x approaches 0, is 1. So this is why L'Hopital's rule is important. It gives us an out for finding cat toys everywhere. Gives us an out for finding limits of functions that cannot be simplified using the standard plan B techniques. So, I want to do one more example of this. Just have to think of what it is first. I think the example should be the limit as x goes to 0 of e to the x minus 1 divided by cosine of x minus 1. I think this is what I want. We'll see. If it's not, I'll just delete this whole video and start over. So, as in all limits, we start with plan A. Plan A will get us e to the 0 minus 1 over the cosine of 0 minus 1. That's 1 minus 1 is 0 on top, 1 minus 1 is 0 on the bottom. That's indeterminate. If I'm spelling this word wrong, don't tell me, I don't want to know. So, this is another kind of problem that we need to go to plan B for, because plan A obviously didn't work out. And again, there's no simplification that you can do here. Nothing will make this prettier or less ugly. There's no way you can simplify this. So, we're going to use LHOP to get derivative of the top will be e to the x minus 1 minus 0. Derivative of the bottom is going to be sine of x, negative sine of x? Yeah, negative sine x. So, we're going to LHOP this and get, plugging 0 into that, we're going to get e to the 0 minus 1 over negative sine of 0, which is 1 minus 1 over 0, which is 0 over 0. There's another indeterminate. I must be spelling that word wrong. Don't look closely at it. So, in this case, we got another indeterminate answer. We have another function that cannot be simplified in any reasonable way. So we're going to use L'Hopital's a second time. LHOP 2. The derivative of the top now will be e to the x. The derivative of the bottom will be negative cosine x. And plugging our value of x into that thing is going to give us e to the 0 over negative cosine 0, which is 1 over negative 1. So the limit of this whole mess, e to the x minus 1 divided by cosine x minus 1, as x approaches 0, the limit of all of that is negative 1 after you use L'Hopital's rule twice. That's it for this video. Be sure to like and subscribe.